Okay. Welcome everybody. Good morning and welcome to this webinar. This is our second installment in our series of webinars focusing on DFOs and its value proposition to the mining industry. Please keep an eye out for our next webinar on the 14th of August at 10. This one is titled Mine-Wide Ventilation and Fire Detection using DFOs. I am Andre Veldsman. I head up Position XT. We are a strategic global partner to Luna Innovations. Then just before we begin, just some housekeeping. There will be a question and answer session at the end of this presentation. Just please type your questions in the box below. And then without further ado, I'll pass the floor over to Herbert.
Good morning, everyone. My name is Herbert Smith. Thank you, Andre, for the kind introduction. I'm from Luna Innovations. I'm the global segment lead for mining. I've been in the mining industry for well over 23 years now, and have been involved with fiber optic sensing and its application within mining for at least the past decade. And today, we will be talking about conveyor fire detection and condition monitoring using distributed fiber optic sensing. As we know, conveyor infrastructure is critical to our operation, and conveyors can span kilometers throughout our operation. And each of these conveyor systems can have thousands of bearings that are prone to failure. Statistically, it's been recorded that 10% of these breakdowns on conveyors are ultimately related to idler failures or roller failures, and noted that these idler roller failures ultimately can lead to friction, which ultimately can lead to a fire. And these fires and mechanical failures, to a large extent, threaten the safety of our miners or operators within our operation, and also lead to significant financial losses and downtime within our operation. You know, as we can see with that little video, that's a small conveyor that's within a mining operation, and you know, and that production cycle, it's worth $270,000 an hour. So can we really afford downtime? But downtime is one thing, but the reality is that there's been a significant amount of conveyor belt fires in the industry that led to really tragic incidences. There's numerous newspaper articles like the ones in the slide, like in China and within South Africa, but it's a worldwide occurrence. And the question really that we should ask, you know, is this what we're looking at, fire prevention, or is it fire fighting? And the reality is, within a mining or in a heavy industrial environment, good housekeeping is fire prevention. But the reality is, there's a lot of unseen risks to our naked eye, such as overloading electrical infrastructure, hot transformers, loose electrical connection, hot bearings and plumber blocks, hot pulleys within conveyor infrastructure, hot rollers failing bearings within conveyor infrastructure. And these risks go unseen in most cases to the operators and the maintenance personnel within those plants. If we have a look at the statistics, it's very interesting that the leading cause of fires in heavy industrial properties, that includes mining, is failure of mechanical heat source. Now, so equipment failure is a massive source of fire. And if we look at what causes these fires, radiant or conducted heat energy from operating equipment. So something to keep in mind is, how does these fires actually start within our conveyors? They don't just burst into flame. The reality is that there is a build-up phase of temperature. As a belt is slipping over a stationary pulley, this belt heats up, it starts to build up thermal energy, the material starts breaking down, and that process is called pyrolysis. Now, that gas is being released is flammable and toxic, and at some point they become volatile, and we have an ignition point, and then we have the chemical reaction we call a fire. And the more thermal energy we have, the more we are staying in this cycle. So to be preventative, we need to pick up the buildup of thermal energy long before we have the release of flammable and toxic gases. And this phenomenon is similar for electrical infrastructure as it is within conveyance infrastructure. As per the 2 slides ago, we had a look at conveyor fire. And here's some pictures of recent fires. This is quite dramatic, the one in Richards Bay, where a failure on a conveyor within a wood chip terminal caused a massive fire and the entire facility and stockpile burning down. Next to it is a little video of a very recent fire a couple of weeks ago within Brazil that also caused severe damage at that mining company. Now, if we look at conveyor belt flammability testing, within this video, we see a belt friction test. As we can see, the hot belt release lots of gases and smoke heating up. And the reality is conveyor belts don't just, as I said, burst into flames. They actually require a significant amount of thermal energy to get to the point of combustion. Now, if we look at the Mine Health and Safety Act, Chapter 8.9.3, states that the employer must prevent the employee from being exposed to flame fumes and smoke and institute measures to detect, prevent, and combat such fires. So regulatory within our South African context, the Mine Health and Safety Act wants us to prevent employees from being exposed to the toxic fumes. Now, then we really have to look at what happens within that process of pyrolysis. As I said, the belt slipping over stationary pulley, roughly 180 degrees Celsius, friction surface temperature, the rubber starts converting into a gaseous state, releasing very toxic gases such as hydrogen fluoride, phosgene, bromide, depending on the type of conveyor. And now, the more flame resistant or flame retardant the conveyor belts that are used in mining, the higher the toxicity of these conveyance systems. Bringing us back to earliest possible thermal detection. By the time we're detecting a fire, it's already too late. And the reality is, the majority of fire detection technology used within existing conveyor installation are exactly that, fire detection. Any heat detection cable needs to be exposed to extreme temperature or a flame to make a contact. Flame detection, that's pretty obvious. It's already on fire. Carbon monoxide monitoring, very typical in underground mining operations. Carbon monoxide is a byproduct of combustion. Hence, there's already a fire. And fire sprinkler, potentially the slowest form of fire detection within a conveyance infrastructure. Again, so these technologies, even though that they are great at fire detection, they are not preventative in nature and ultimately won't get us to comply to the Mine Health and Safety Act requirement of preventing employees being exposed to fumes and smoke. But before we get to a dramatic fire on a conveyor belt, there's some other stuff that happened even before that. Some component or part thereof needs to start failing, and that creates the need for condition monitoring. As you can see in this video, very late stage failure on that roller with already releasing thermal energy and knocking severely. Now, these aren't uncommon sites within the mining and heavy industrial sector. Rollers getting stuck, ultimately shaving through, creating a mass of material that's flammable, thermal energy, and ultimately we get to a point of a fire. The biggest problem with this, though, is that even though this is not uncommon, we are still relying on an individual to walk along a conveyor infrastructure for kilometers thereof potentially only on the one side of a moving machinery to inspect if there's any failing or condition of faulty rollers and idlers along the length thereof, which is extremely impractical. That miner has to contend with extreme temperature changes, inclines, declines, uneven surfaces, and generally, it's a person who potentially is having a bad day. And the reality is this is not practical. So what we offer to the market is a nervous system for your conveyor. So, and ultimately, as we have a biological nervous system, and you can touch and feel with your fingers, and you can feel the temperature and the vibration of an object, so can we use a fiber optic cable to monitor certain aspects such as vibration, strain, or pull or stretch, and ultimately temperature. So a fiber optic cable has the ability to convert the signal into an optical signal in the change of our light pulses, and we can interrogate this change within the fiber optic cable and give us an absolute actual value what's happening along the entire fiber optic cable. This allows us then to take control and action on any issues along the length of that fiber optic cable, and hence the installation on the conveyor. So within this slide, what we would have is we would have the fiber optic cable running all along the conveyor infrastructure for the entire length thereof on either side, connected to our interrogated unit, which in turn then interrogates one for the condition monitoring, the vibration along the conveyor, as well as the temperature system to do the temperature side. The heart of this system is our sensor cable. The fiber optic cable is the sensing instrument. There's nothing else connected to it. The cable itself is the sensor. Now, depending on applications, we can measure comfortably from -80 to about +500. And in some special applications, we can go -180 to +1000, depending on the sensor cable construction. Being fiber optic, we are immune for vibration, for explosive environment, for radiation. Nothing affects our sensibility within our system. So it's absolutely inherent. The system for a fire prevention application carries full FM ULC VDS EN certification as well. As I said, that previous slide, that we can see the temperature profile along the entire fiber. And to explain this in the most layman terms, if you would think about a little bottle of water, we heat up the water, the molecules become more active inside. And if we cool the water, the molecules become more stable until the water is frozen. And the same happens within that silica glass. Now, if we heat the silica glass and it bounces around, and as we would shine a light through a bottle of water and we shake it, we'll see the little bottle of water glows as the light hits those molecules bouncing around. We now shine a laser through that fiber optic cable. Now that laser hits those molecules, creates reflection. The intensity of the reflection, or we call it backscatter, integrated is our temperature measurement. And the frequency of light throughout the cable is our distance or temperature points. But ultimately, we very accurately see the temperature profile along the entire fiber optic cable. And we go and break that down into zones for every specific area of interest along that infrastructure. So this is just a little picture of how our temperature sensing system looks like. I'm not gonna, for the benefit of time, not bore with too much of the details, but ultimately the system can 6 kilometers per channel, up to 4 channels. We have a potential measurement resolution down to 25 centimeters and a temperature resolution down to 0.01 degrees Celsius. But the most important is that for every area of interest along that entire conveyance system, head, tail, take up, drive, even the electrical infrastructure driving it, we can set up 5 unique pre-alarm and 5 unique alarm parameter sets for maximum temperature, for hotspot along the conveyor, and 3 delta T's, the rate of rise in temperatures, so that we can very early accurately pick up radiant heat from a pulley, from a roller, from frictional heat from the belt against the structure, or any external event to the belt. Here's a quick animation of this system. Within that conveyor infrastructure, there's an infrared lamp. When the infrared lamp switches on, you can see the temperature building. We can visualize exactly where that's happening. There you can see the temperature going up. And with our temperature gradient scale, we can exactly show where that thermal energy is within any object. In this case, for this application, a conveyor belt infrastructure. And then within the next webinar, we will explore some other applications for this technology. Here's a real world incident. This was at a coal terminal in Mozambique. The technicians were commissioning the fiber optic sensing system. So they were heating up the beginning and the end of each of the conveyors. And when they looked at the temperatures, they saw the spike on conveyor 11. And when they investigated, they saw that the pulley were building up frictional heating against the spillage. As you can see, the smoke and the thermal energy coming off that very hot pulley, and how effectively we measured that incident. The technician then pulled the pull key, tripped the belt, and called maintenance personnel to come and investigate further. This is more than enough for us to be a delta over average, a hotspot indication to trip a hot belt. Back to the condition monitoring part thereof, this is our vibration or acoustic sensing system, where we have 7 kilometers per channel. We have a resolution down to pretty much every single idler frame along a conveyor. And what this system does, it monitors as a process run every single frame along a conveyor. And we interrogate the acoustic information at that frame, and we compare those acoustic signatures to known values, such as knocking, squealing, that has a very specific acoustic profile, rattling, squeaking, and rumbling, very early failures. Now, as we then interrogate all these signatures at every single idler frame, we then output a report, and within this report, for every single frame, we give what's the intensity values for each of those signatures: knocking, squealing, rattling, squealing, rumbling, and an overall intensity. So this allows us to, and we can run this process as many times during a shift as needed, and we then use this report for the maintenance teams to know exactly where on their conveyance infrastructure they need to go and replace potentially failing rollers, allowing us much easier maintenance and reducing our risk of failures due to faulty idlers significantly. So what does this mean in rands and cents terms? 3%, up to 3% more conveyor belt availability. 10% reduction in hours of unplanned maintenance, because unplanned maintenance on idlers is not something of history, because we have a report that shows us where to maintain, and we maintain accordingly. Massive reduction on the hour spent of an individual having to walk a conveyor belt. And this is just wasted time and wasted money. Now we have that time available to do maintenance within our infrastructure, to ensure uptime and other assets within our operation. 90% reduction in annually due to failure, because we replace them very early on. So we don't wait for late-stage failures. And ultimately, these late-stage failures lead to other conveyor belt issues, the spillage, tracking issues, belt misalignment issues. And then the biggest thing at the end of the day is, by monitoring as early as possible the failure and the rollers, idlers themselves, as well as the thermal energies, the temperature throughout the entire conveyor infrastructure, we can practically get to a point where we prevent fires on conveyor infrastructure. Here's a quick calculation that we've done for a customer. We worked on with this mine. It's a coal mine. The current production on that conveyor belt is 4,000 tons per hour. We then looked at, by using and deploying the system, the increase in conveyor belt availability, and that ultimately led to an increase in production value of $13,000. For their network and deployment on their systems was about $2.5 million. And the return on investment on the system was only 2 weeks to recover the cost. This includes time, other breakdown costs, material spend. This is purely the conveyor belt being more available to move more material due to less idler failure on the belt itself. We can go into some questions just now. Just keep in mind, mark your calendars for upcoming events where I will be discussing mine ventilation and fire detection using fiber optic sensing. And after that, talking about pipeline and strata safety, but more on that later. Feel free to scan the QR code and please reach out with questions.
Hi, I don't see any questions yet there, Herbert. Let's see if no questions yet. Let's give it maybe a minute or so. Nisa, if you can just maybe launch that questionnaire for us, that'd be great. Okay, I see one question come in. Okay, what is the reaction time to a sensing incident to deployment? Sample rate, pretty much.
So our reaction time on what we've experienced with real world incidences is that from the moment that we have a stuck roller that is over 150 degrees Celsius, we detect that radiant heat energy within 3 minutes in an environment. Keep in mind the fiber optic sensing cable is about a half a meter away, and we're very reliant on the radiant heat release. But the hotter the object is something like a pulley slipping in a belt or a belt within a pulley, our reaction time would be a lot faster, within a minute.
Okay, then we've got another one. Does the system allow for remote monitoring?
Remote monitoring in the sense that the interrogator unit can sit within a control room environment or within an electrical substation, and connected to that is the fiber optic sensing cable running throughout the conveyance infrastructure. So it's not there's the IoT type sensors, which you have RF sensors, making it ideal for mining and heavy industrial environments.
Okay. And then is it possible to connect or integrate the temperature monitoring system with a fire protection system already installed in the infrastructure?
Yes, it is. And it is ideal because we go from suppressing a fire to cooling a hot belt. We have several outputs available on our systems. The systems can be configured with up to 104 digital outputs. These outputs can then control various deluge valves and suppression systems depending on the application, as well as integrate into PLC and emergency stop circuits to stop and control the valve.
Okay. Where in South Africa has this system been used?
We have a deployment of now over 530 kilometers of equipment supplied to conveyance projects in South Africa. It has been used throughout Impala, Rimplat, Ivanplat. We can share a long list of customers. It has been adopted quite widely within the mining, let's say, infrastructure into South Africa.
Okay. Is the fiber optic cable embedded in the conveyor belt system itself, or is it measuring ambient temperature?
The fiber optic cable is not in the belt itself. It is within the structure itself. So you would run it along the stringer line. So it's within the conveyance structure, measuring the ambient temperature within the structure.
How much conveyor downtime is required to install the DFOS system?
I guess the only question is how much guarding do we need to remove to get onto the belt? But typically, we can do about 500 meters of conveyors within a day, depending on accessibility.
Okay. Okay, that was it. I don't have any more questions from this side. So from my side, everybody, that will be it. Like we said, please keep an eye out for our next session. And thank you for joining, Robert.
Thank you. Thank you for the opportunity. Thank you for everyone that attended.
Thanks, and goodbye.
Thank you. Bye.